This is an interesting question. Not only is it a trigonometric integration, but we're also being asked to solve, i.e. to find the value of x. And we're given a range from 0 to pi over 2. So if you look carefully, you can see that we have a tan and a secant. Now you could use the reverse chain rule, keeping in mind that the derivative of secant x is secant x tan x. And that's really useful because we have secant x to the power 4, and you can, I guess, rewrite that as secant x to the power 3 times secant x. So this secant x to the power 4 we can rewrite as secant times secant to the power 3. And that way it allows us this convenient tan x secant x that we can use for the reverse chain rule. And I've just taken the 5 outside of the integration. Now, if you're not a fan of the reverse chain rule, we can use substitution. I can say u equals secant x, so du by dx is secant x tan x, and therefore dx is du divided by secant x tan x. So I can then rewrite my integration as 5 times the integration of tan x times secant x times u to the power 3 multiplied by du divided by secant x tan x. And what we also need to do is to rewrite the limits, because what we have is limits for x. We now need to replace with limits for u. And u is simply secant x. So I can simply replace theta with secant theta and replace 0 with secant 0. And secant 0 is 1 over cosine 0, which is just 1. So it's 1 over 1. So that's our question. And now it looks much nicer, I guess, because we can cancel everything that has an x in it. And our integral now boils down to 5 times the integral from 1 to sec theta of u to the power 3 du. And it's actually an equation, so we still have a right-hand side, 15 over 4. Now we can divide both sides by 5, I guess. If I divide both sides by 5, I then have the integral from 1 to sec theta of u cubed du equals 3 over 4. And the integral of u to the power 3 is simply u to the power 4 over 4. And then we have our limits from 1 to secant theta equals 3 over 4. Again, let's just multiply by 4. And then you've got secant to the power 4 theta minus 1 equals 3. Now it's looking much nicer. It's looking like a trig question. So now we have secant to the power 4 theta equals 4. So secant theta is plus or minus the 4th root of 4. So secant theta is simply plus or minus root 2. So that means that cosine theta is plus or minus 1 over root 2. So theta would be cosine inverse of 1 over root 2, or theta 2 is cosine inverse negative 1 over root 2. So the inverse cosine of 1 over root 2 is pi over 4 in radians, and in the range of 0 to pi over 2, cosine is never negative, so that is out of the range. So that is your final answer. Theta equals pi over 4. So that's the answer to this question.